Yeah, yeah, guys. Very good afternoon. So yesterday we discussed the threaded threads and screws. Okay, threaded fasteners we discussed. I mean, still remaining topics, remaining content we discussed today, and please try to cooperate today. We try to finish today this threaded screws. I mean, thread portion we have to complete today. It may take 1.5 hours. Please cooperate today to complete this topic. And the next class we start power screws. We try to complete today. Okay. So I share my screen. Are you able to see my screen? Hello. Are you able
Yes,
to?
sir. Yes,
Okay.
sir.
So yesterday we discussed. I mean, small problems, simple problems we discussed yesterday. Just a recap yesterday what we discussed. I mean, these are the things we discussed yesterday: bolt joints and simple analysis. Some more theories we discussed yesterday. I mean, one more theory we didn't discuss. Now, first we discussed that for a few minutes, then we go for our today content. Okay. See, I mean, materials and manufacture. How to? What are the materials we are going to use for preparing the? Bolt and nut, right? I mean, I'm going to tell you briefly. Remaining things you go through that the material part you can easily understand and you can prepare your own. I mean, see here, light loaded small bolts, studs, and nuts that can be prepared using free cutting steels. But high strength bolt, I mean, which bolts are getting failed due to fatigue. That type of bolt we are preparing using plain carbon steels. Plain carbon steels, for example, 40C8, 45C8, such a material we are using. Plain carbon steels we are using for preparing the high strength bolts. And also alloy steels. Alloy steels we are using for preparing the high strength bolt and nut. Okay, I mean the stainless steel is used for the threaded fasteners. I mean, where the corrosion resistance is required. I mean, wherever corrosion resistance is more, that place we can use the bolt and nut, which material prepared by using stainless steel. Stainless steel bolt and nuts highly suitable where the corrosion occur more, that place we can use that because stainless steel is high corrosive resistant material. Okay, I mean, what are the methods to manufacturing the uh, bolt? There are two methods. One is, I mean, thread cutting method. Another one is thread rolling method. Thread cutting method is done in automatic machines called screw machines. Even we can do our lathe machines, right? Okay, that is under thread cutting method. Whatever we are using, I mean machinings, I mean lathe machines for cutting the threads. That is thread cutting methods. And the rolling method. The rolling method is, I mean, the thread rolling method is one of the best method. But here, the threads are formed by rolling the bar stock between the two dies. Between the two dies, when we are passes the which cylindrical rod, we are passes through the between the rolling bar stock. Then, due to the depress the part of the cylindrical material going to be formed the threads. But here, the material removal rate is very less, I mean almost nil, almost zero. But in material removal rate is there in thread cutting machine. Okay, these are the things. I mean, please go through that. This is the theory. You can easily get it once you are reading the book. Now, what is the advantages while going for the thread rolling method for preparing the threads? I means that they improve the fatigue strength. If you go with thread rolling method, the fatigue strength can be improved. Okay, and the stress concentration going to be reduced. Okay, and But in thread cutting machine, the results cutting in the fiber lines are fiber lines of the original bar stock. I mean, we discussed earlier chapters. That's the fiber lines. If it will be when we are going for any machining process, we are cutting the fiber lines. The streamlined fiber lines we are cutting in the machining process. Hence, the material lose their strength. Similarly, when you are going for thread cutting using, making threads using thread cutting method, the stream lines are going to be distorted. Hence, the material losing the strength. I mean, the thread, the bolt is losing the strength. But here, when we are going for thread rolling operations, the fiber lines are rearranged. Hence, the material that the bolt strength going to be improved. Bolt strength going to be improved. These are the important difference. Okay. So please go through that. You can get it more information. But about the material and thread rolling, thread rolling and thread cutting process, you can get more information. Yesterday we started this. The eccentrically loaded bolts and joints in shear. Eccentrically joined. See here, how we are saying eccentrically joined. Oh, okay. That figure is not here. Okay, anyway, see here. In structural connections, in particular applications, we are using group of bolts. For example, this one, you might have been seen this kind of bracket connected in the frame. Then we can't use single bolt. We have to use multiple bolt and screw for securely hold the bracket. Right? Right. Okay. Yeah, that's what we are using group of bolts for frequently employed to hold the component. For example, this is the bracket connected in the frame. Here we are using group of bolts. We are using group of bolts in this bracket. Now see here, this is center of gravity here. This is center of gravity here. Okay, the force is acting in the bracket, right? In the offset distance here, E from the center line, center point to the here, the E distance is E. Okay, now see here, there are 4 bolts and nuts we are using. This is the component 1, this is the component 2. With the help of these 2 components is connected with the help of the bolt and nuts. Okay, now I can do like this for your understanding. This because the design and how they are connected very important. Then only the later concept you can easily understand. How can I find out this center of gravity? Now see here, the bolt 1, 2, 3, 4 bolt area A1, A2, A3, A4, A5. Here we are using 4 bolts A1, A2, A3, A4. This coordinates from center. This is one coordinate. This is sitting another coordinate. This is sitting another coordinate, right? Then this is sitting another coordinate. Now, you can see clearly here. A1, A2, A3, A4, A5, like that. The bolts are located in this position. Now, how can I find out this center of gravity? Now, the G is the center of gravity of the group of bolts. Here the coordinate system is given x1, y1. We must know the coordinate system where it is located, the bolts. Then if we know these coordinates, we are able to find out the center of gravity with respect to coordinates x and y, right? That is nothing but location of the center of gravity. With respect to x-axis, area of the bolt into x1 plus area of bolt into x2 plus area of bolt x3, like that, based on number of bolts. Then divided by A1 plus A2 plus A3 plus A4. This will give the location of the center of gravity with respect to x-axis. Similarly, we can find out the location of the location of the center of gravity with respect to y-axis. This one. Okay. Now, see here. I mean, this is the eccentrically loaded bolted connection. See here, this is eccentrically loaded bolted connection. In this, the external load P is acting E distance from this is the opposite distance from the center of gravity E. Okay. I mean, see here, the eccentric force can be considered equivalent imaginary force P at the center of gravity. I mean, the force is acting here downward direction, which where it is acting downward direction here. Obviously, the force must be acting here upward direction for maintaining the equilibrium condition of the entire system. Hence, the force is acting P in upward direction at the center of gravity. That's what we are saying. The force is acting P at the center of gravity for maintaining the compound in the equilibrium condition. Okay. Now, the center of gravity. Now, I mean, at the center of gravity, and this moment, what is the moment? Because the force is offsetted from the center of the component. Hence, we can want bending moment must be there. Then, how can I find out the bending moment? This is a vertical distance, vertical force into horizontal distance, P into E. This is moment, P into E. Now, see here we are dealing with the two types of forces. See, the bolt is connected here. The direct force, the P is directly acting on each bolt. The P is directly acting on each bolt. That is going to be a primary force. Okay, that is going to be a primary shearing force. Okay, that primary shearing force, it will be equally distributed to all the bolts. Hence, we are saying that the primary force we are considering P1 dash current the corresponding bolt, or bolt 2 corresponding bolt to P2 dash, corresponding bolt to P3 dash, corresponding bolt to P4, it's a P4 dash. We are considering like this, but uniformly distributed. Then this is upward force, means the force is acting in the end of the bracket acting downward, then it should be upward for maintaining the equilibrium condition. Then this force is going to be distributed equally in all the bolts and nuts. Hence, this is the primary shear force. This is the primary shear force. Because, see here, I mean, we can't say tensile force. Because see here, if tensile force means it should be perpendicular my board. And it should be along the cross section, it should be axial direction of the bolt. But here it's not like that. This force is perpendicular to our bolt axis, which force P is perpendicular to our bolt axis. Hence, this is shear force. I mean, due to direct load, P, the force developed in the bolts and nuts, it is called primary shear force. But another shear force also going to be here because, I mean, based on the movement. Based on the movement, another shearing force going to be here based on the movement. The movement is nothing but P into E, how much load, vertical load and horizontal distance from the center of gravity. Then that is the movement. Based on that movement, we are able to find out the secondary shearing force. Secondary shearing force. This the primary force is nothing but P1 dash is equal to P2 dash is equal to P3 dash is equal to P4 dash, P by number of bolts. Number of bolts. Now, this is the moment with respect to center of the gravity is the secondary force, shearing force, P2 dash, P1 double prime, P2 double prime, then P3 double prime, then P4 double prime, number of bolts is 4. Then this is a secondary shearing force with respect to bending moment. Now, we know the bending moment, P into E in left hand side. With respect to bolted joint, how can I find out bending moment? Now, see here, shearing force, P here, we know the distance from the center of gravity. P1 into P1 double prime into distance R1 plus P2 double prime distance R2 plus P3 double prime distance R3. See here, then P4 double prime distance R4. This is the, I mean, this way we are able to find out the secondary shearing force with respect to bending moment. Now, I mean, see here, the secondary steering force of any bolt proportional to the distance from the center of gravity. They mean central. I mean, always the force, secondary force always proportional to the center of the gravity. So P1 double prime is equal to R1. I mean, see here nothing but the force P double prime proportional to R1. Okay, because if R1 increases, the force also going to increase. Now I remove the proportional, then P double prime is equal to CR1. I mean, later the derivation, furthermore derivation we are going to discuss in different approach. That time you can clearly understand. I mean, I have explained there also. I'm going to explain there also. Sorry. Okay. I'm going to explain there also how the P is proportional to L1, how the P is proportional to L2. Like that, we are going to discuss later. But just to keep in mind, in generally, when this P, I mean, load is proportional to R. Suppose the load, the here R1 distance keep on increases. Obviously, force is going to be increased. Hence, we are using direct relations here. P1 double prime, the secondary steering force proportional to R1. Proportional to R1. So the secondary steering force, this is a P1 with respect to bolt 1. I mean, this is a P2 with respect to bolt 2. P2 double prime is equal to CR2. Okay. Now, a P4 double prime is equal to CR4. Now, I mean, now I'm introducing this. I'm substituting this P1 double prime values in this main equation. Okay. Now we able to find out what is C1. Sorry, what is C? C is nothing but PE divided by R1 squared plus R2 squared plus R3 squared plus R power 4. R4 power 2. Okay, R4 power 2. From this, again substitute this C value here. Again substitute the C value here. Then we are going to get P1 double prime value, the secondary steering force at with respect to bolt 1 we can get, secondary steering force at bolt with P2 we can, P2 double prime we can get it. Okay, now see here. I mean, how the force is acting here. See, this is a vertical force P1 frame. See here, this is a, primary and secondary steering force, how it is acting in the bolt. Schematic diagram. See here, P1 is acting because here the load is acting downward. Here the load is, here the load P is acting here, right? P is acting here. Then this P is acting in the center of the gravity. It's a direct shear force. Then this is upward direction. Okay, sorry, actually I put a direction in downward because here the force acting upward, downward, sorry, in this end of the bracket acting downward. Acting downward. Now this force, suppose no bolt, what will happen? Should be upward direction. When this here it will act upward direction, then sorry, here should be downward direction. The bolt, each bolt should be, I write it here. Here downward direction, here the force acting upward direction. Then this bolt, these two bolts are identical. This bolt is acting upward direction, this bolt is acting upward direction. Then now this should be downward direction. Because now these forces, all these forces, the summation of these forces with respect to bolt 1 here acting upward direction, right? Yeah, this bolt force acting upward direction, this bolt force acting upward direction, this bolt force acting upward direction, this bolt force acting in upward direction. It should be all summation should be equal to this force. Suppose, I mean, I did one mistake early. Why I did that mistake, I tell you now. I mean, suppose if I use only one bolt, for example, that's what I thought to tell. I forgot that. Suppose if you use only one bolt at the center, then the force is acting upward, down, upward. Okay, so that's what I thought to tell you initially, but I forgot it. Please consider now. Initially, but I mean, practically now the bolt is not presenting in the center of the bracket. Hence, now in the center of gravity the force is acting downward. Now this force must be equal to summation of the force which forces are acting in the all the bolts. I mean that force is a primary force. Primary force 1 plus primary force 2, the summation. These all forces P1 dash plus P2 dash plus P3 dash plus P4 dash going to be equal to must be equal to our force acting P here. Then the system going to be equilibrium condition. Now I come to this is a primary and secondary force. This is the primary force shearing force. This is the primary force shearing force acting upward. This primary force acting upward. This primary force acting upward. Now see here, this bolt how it will be acting secondary shearing force. Obviously when this is the load acting here, this is the nut going to be a secondary force, this one. Okay, now this nut going to be, I mean this nut 1 and 2 in opposite manner, 1 and 2. See here, this nut, the secondary force going to be acting here. I mean then only equilibrium condition. Now I take nut 2 3 2 and 3, now 2 and 3, but if we acting like this, the shearing force, secondary shearing force, obviously here going to be downward direction. You may ask that how can I define initially upward or downward? Right? Then in this, first you start from any one of the bolt. I mean any one of the bolt. I mean here the force is acting here upward. Then obviously that I mean this secondary shearing force going to be act opposite direction of this. Okay. Then once you define this bolt you can, based on this bolt you can easily define it will going to be acting like this. Once you define this bolt, I mean if define this bolt are going to be in opposite. Okay, I mean you may start from here also, then when this bolt is going to be upward direction, obviously this bolt is going to be downward direction. So this is sign and direction, very easy. You start, suppose if you are starting from this bolt, I mean this is upward direction, or this is the primary shearing force is always not upward direction. But here if you start, this force is a downward direction, then this is the secondary shearing force also going to be down this direction. Then another opposite nut going to be upward direction. Then opposite nut going to be upward direction. Then this nut is downward direction. This nut going to be upward direction. It should be making a couple. Then should be a perfect couple and should be a equilibrium. Now see, come to now our intention is to find out the shearing forces, secondary shearing force, primary shearing force. We have discussed. Now we would like to find out the resultant force. What is the resultant force? I mean, obviously, see here, one force is acting upward direction. Obviously, another force is acting, the secondary shearing force acting in this direction. This is, I mean, looks like, I mean, parallelogram, right? Then two forces are acting here. This is very basic. You can easily understand. Now, the primary and secondary shearing forces added by the vector addition, method to get the resultant shear forces P1, P2. Here, see here, this is the resultant forces. This is resultant forces are here. This one. This is the resultant force P4. This is the resultant force P2. This is the resultant force P1. This is the resultant force P3. Because two shearing forces are acting, hence we are going to find out the resultant force. Resultant force P1, P2, P3, P4. In this analysis, I mean, now I come to this next page, you can understand. Okay, yeah, it is not explained, I think so. Now, yeah. Yeah, during problem, we are going to discuss the problem. During that time we can easily understand. Okay, I write the formula in here. This is the, okay, it is here, the conclusion given. Do you have any doubt up to this? Yeah, please go ahead. Suppose any doubt, because this is very important. I mean, if you are clearly understanding this concept, later there we are going to discuss two more concepts you can easily understand. Any doubt in this? Hello, guys. Someone reflect, please.
Yes, sir.
Shall we move to next?
Yes, sir. We can move further.
Thank you. Now, I mean, just conclusion about this what we discussed. Now, just step here. This is the, I have put here on here. This is whatever we discussed. This is some step by step what we should follow. I have been explained here. This is, now this is secondary force, how we are calculating. Please don't worry about secondary force. Secondary shear force we are going to discuss. I mean, sorry, I mean resultant force. Secondary shear force you might have been understood. Primary shearing force you might have been understood. But the resultant force, we are going to discuss the problem. That time you are sure, damn sure you are going to understand. No problem. I will explain you there. Okay. Now these are the standard. D is equal to, I mean, DC is equal to 0.8 times D. Yesterday we discussed this kind of formula. Yesterday we discussed. This is now okay. Now, yeah, this is, I thought to put early. This is here. For, I mean, for our understanding, I want to show here. This is the bracket. In this bracket, now this is our bracket is connected like this. Okay, later case it will be a different orientation. Now we move to the problem. This problem you can understand easily the resultant force. See the problem. I mean, this is the structural connection. See, this is a structural connection shown in the figure C here. I mean, this subjected to the eccentric force 10 kilonewton with the and eccentricity of 500 mm, 500 mm from the CG, from here to the 500 mm from here to here. This is 500 mm. Here to here 500 mm. Length is given 500 mm. And the ball 500 mm of the balls, the center distance between the balls 1 and 2 given 200 mm. I mean 1 and 2. 1 and 2 is 200 mm. This is 200 mm. Now the center distance between the bolt 1 and 3, 150 mm. This is a vertical distance is given 150 mm. 150 mm. Okay. Now 150 mm. Now, and the 150 mm, all the bolts are identical. The bolts are made from the plain carbon steel 30C8. I mean, yield strength is given 400 Newton per mm squared, and factor of safety is 2.5 mm. 2.5, sorry, 2.5. Determine the size of the bolt. Now, this is a given data just now we discussed. Okay, factor of safety, yield strength, everything. Now come to the permissible shear stress. I mean, this also standard method, permissible shear stress. Now in this design of the bolt, in this design, we are going to deal with the primary shears and secondary shear force. Hence, only we are considering that permissible shear. We are considering this only, permissible shear strength only we are considering. Okay. Now permissible shear is nothing but 0.5 times SYT divided by Fs. Now come to this. primary and secondary steering force. Primary steering force. I mean, before going for the primary steering force, we have to understand what is R1 to R2 R3 distance. Now, what is R1 distance? Now, this is our R1 distance. As per the earlier discussion, this is R1 distance. This is R2 distance. This is R3 distance. R4. This is R3 distance. Now we would like to find out that distance. Now, what I'm saying, what I'm taking here, whatever we discussed earlier, the top half portion only I'm taking for our calculation. Remaining things are symmetric. These two only I'm taking for our calculation. Okay, that's what. Yeah, now see here. Now, I mean, the bolt is at 1 and 3. Here, 1 is sitting here. Here, this is 1. 3 is sitting here, but only I'm taking the top portion only. Okay. Now, the 1 and 3 is sitting here, 75 mm. Because 1 and 3, between the distance 150 mm. But what is the center distance between 1 and center, say, CG? I mean, vertical distance from bolt 1 to CG is 75 mm, because overall distance is 150 mm, then this is 75 mm. Now the horizontal distance is 200 mm, then this is the center of distance. I mean, this is nothing but y bar, this is nothing but x bar, 100 mm. Once we know that, we can find out what is this R. R1, R2 we know. Here R1 is equal to R2 is equal to R3, all the cases. Hence here R is equal to 125 mm. Once we able to find out R, then we can go for the finding our secondary shearing stress. The primary shearing stress is a direct shear. Directly we can calculate it. The load is eccentric load is at 10 kilonewton. Then 10 kilonewton divided by number of bolts, it will give us, I mean, each bolt how much primary shear is involved. How much primary shearing force involved at each bolt is 2500 Newton. All are in acting upward direction or upward direction. Now, secondary shearing force. Secondary shearing force, we already discussed the formula here. See here, I mean, this one, secondary shearing force, I mean, P1 dash is equal to this, P2 dash is equal to this, nothing but PE into R1 divided by L1 squared plus L2 squared plus L3 squared plus L4 squared. Okay. Now substitute there, we are going to get primary force P1 dash, P1 double prime. Primary force, I mean, all bolts are sitting in same radial direction. Hence, here also P1 double prime, P2 double prime, P3 double prime, P4 double prime. The secondary shearing forces are same because all bolts are sitting same distance compared with the center of gravity. Okay. Hence, here shearing force for bolt 1 is secondary shearing force of bolt 1 is 10,000 Newton. Secondary shearing force of bolt 2 third secondary shearing force of bolt 3, secondary shearing force of bolt 4, all are in 10,000 Newton. Is 10,000 Newton. Now come to this finding the resultant force. Now this is very important. That's this is very important here. Now what is the formula? Now see here, P1. Now this is our resultant shear. Resultant shear is resultant force is acting here. The resultant force is acting here. This is the resultant force acting here. P2. Now this is you might have been studied in engineering mechanics. These the two parallelogram forces are acting. How to find out the resultant force? The same formula executed here. Now I write this. You can understand. P1 is equal to resultant force. P1 is equal to P1 P double frame. No, here P double frame squared P1. This force P double frame squared this force and P double frame squared into E plus P1 frame squared P1 shear, this is secondary shear, primary is here, okay, minus 2p1 double frame 2p prime cos theta. This is the resultant force acting in this bolt. Now, see here. Now, if I'm taking here, see one important thing. When we are considering sharing, I mean resultant force here, the two forces are in opposite direction. See here, this force is acting upward direction. The P1 prime is acting upward direction. Okay, P1 prime, but the P2 prime acting in downward direction. Acting in downward direction. Hence, here that's what here we if you solve this, I mean this if you solve this at P, if you simplify this P1, you are going to get the equation P1 double prime cos theta minus P1 prime whole squared plus P1 double prime sine theta whole squared. This is very simple concept. You might have been studied. Just try. Okay. Now come to here. These two forces are in opposite directions. Hence here minus sign. But when you come to this bolt, I mean the two forces are in same direction. This is the P1 prime. This is what it is. This is P1 double frame. Sorry, I did a mistake. P2. This is a bolt 2 now. Now we are in the bolt 2. Now this is the P2 frame. This is a P2 double frame. P2 double frame here. P2 double frame. I mean both are in upward direction, and don't worry. Just you put a plus sign here. I mean, whatever we discussed, the same equation. Now these two forces are now upward direction. Just you put plus sign here. Now put plus sign here. Instead of this minus sign, I am putting plus sign because the two forces are in same direction. I am putting plus sign. Then remaining things are same concept. Suppose if you go for, suppose if I want to find out this now R1 is same, R2 is, this is R2, this is R1, all are same distance. We are using this, right? Suppose I would like to go for bolt 3, bolt 4, then what will you do? See here in this case, now I come to this case and this case I am taking. Now this is going to become minus sign. This is the force acting upward direction, one is downward direction. Then finding the resultant force, there should be, how can I find out? This is, P in this case P1, P3 double frame here, P3 double frame cos theta minus P3 frame, P3 double frame cos theta minus P3 frame whole squared plus P3 double frame sine squared theta. P3 double frame sine theta whole squared, then whole square root. Okay. Here minus sign root. Here should be plus. Plus in that sense, P4 double frame cos theta plus P4 in one frame. Then this is going to be squared. Then plus P4 double frame sine theta whole square. That's all. So you know each bolt how to find out the resultant shear load. That is very important. Resultant load you have to find out. Now the same manner, see here, now we have found that, we already know P1 P double frame cos theta is nothing but this vertical distance, 75 mm, this horizontal distance 100 mm. We are able to find out what is the theta. Then find out the resultant force at bolt 1. Then find out the resultant force at bolt 2. Bolt 2. See here, this is a plus sign here. Okay. Now, which one is more? Which one is more shear load, more resultant load? This bolt or this bolt? This is the bolt 2 is more shear load. Hence, we can consider for our bolt design, bolt size, finding the bolt design and finding the bolt dimension, we can consider the more shear force. More resultant force we have to consider. Now, more resultant force, then what? Because here shear load only, shear force only. Then I mean tau is equal to P2 by A. Then from this relation, we are able to find out the diameter of the, I mean core diameter or minor diameter of the bolt. Minor diameter of the bolt is DC is equal to 13.87. Okay. And I mean, come to this. I mean, you may ask us where is a P3, P4. I mean, this is identical. Then that also it will come similarly. So symmetrical because the distance are symmetrical. R1, this is R1, this is R4, R2, R2, R3 symmetrical, R1 and R4 symmetrical. Hence, I didn't go for that calculation. Only P1, P2 only I have found it. Now P2 is more, that only we have to consider for our design consideration. Now, I mean, from this, I mean, tau shear stress is equal to P2 by A. From this relation, we have to find out our core diameter or minor diameter of the bolt. Now, I mean, what is this our major diameter? I mean, core diameter. What is this? This is 18 mm. Our D is equal to 18 mm. This is earlier relations we used. I mean, DC is equal to 0.8 times of D. Then this is our nominal diameter of the bolt. I mean, go to the bolt, go to the table. You able to find out to which notation. I mean, we isometric thread fine series and core series. We have to find out like this dimension, this diameter, this nominal diameter belongs to which category? Which category of bolt? That is M20. Anyway, I show you. Oh, okay. Here I don't have. I mean, next I will have. I will show you next. Okay. Now I come to the next problem. If you have any doubt, please ask me. Now a steel plate is subjected to force of 5 kilonewton. Here this is a 5 kilonewton subjected to, and the fixed channel by means of three identical bolts as shown here. These all bolts are sitting in the same plane and same line. Same line. The bolts are made of plain carbon steel. I mean, this is a shear strength. I mean, yield strength they have been given, and the factor of set is 3. I mean, specify the size of the bolts. Here also our aim is find the size of the bolt. This is simple problem. See here, the load is acting here downward direction at the end of the channel 5 kilonewton. The load is acting 200 mm. What is the center? I mean the opposite distance from the center of gravity 305 mm. See here 75 plus 30 plus 200 305 mm opposite distance from the center of gravity. Okay. Now this is the I mean other things are clearly given. The center distance between the center of gravity to the bolt 375 mm. Center the distance between the center distance between the center here bolt 2 to here one is 75 mm, but the bolt 2 is sitting at the center of gravity, at the center of the gravity. Now find out this. I mean here also the earlier concept what we applied is similar concept but a simple problem. Now come to here, this is the to find the permissible shear stress value. Then next case, I mean the step 2 we are going to find out the primary and secondary force. Here total bolt is acting 3, then 5000 divided by 3. This is each load directly sharing the shear stress. Shear load is each bolt directly sharing the shear load is 666.667 Newton. Now secondary shearing force. I mean, secondary shearing force, we already discussed the formula early. I mean, this is all are sitting in same radius, 75 and 75. Then, but only this is the 2 bolts are considerable because the center bolt 2 is sitting on the center CG. Hence the distance we are assuming that 0. Hence only R1 squared plus R2 squared plus R3 squared. R3 squared means CG distance is 0. Hence that is 0. Only we are taking R1 squared plus R3 squared. Now find out this. This is a secondary shearing force with respect to our bending moment. Bending moment. Okay. Now this is once we have found it, to come to this resultant shear force. Resultant shear force. Now, I mean here resultant shear force also very easy because directly you have to sum it. I mean P3 resultant shear force. Here how much is shearing force here? Because this is a 2 4 there, two forces are parallelogram. I mean the earlier case is a different, this case is different, then directly you can sum it the shearing, I mean the horizontal only here, the force component here. Okay, see here they clearly given here. This is the force P3 dash shearing force, primary shearing force at bolt P3 dash, primary shearing force at bolt 1 P1 dash. This is a bolt at 2 P2 dash. Now secondary shearing force, the bending moment. This is a P into E. Okay, this is a bending moment acting in the center of the bolt. Center of the bolt. Now, I mean, here center of the bolt. Now I'm considering the bolt is the force upward direction. So obviously this bolt going to be downward direction. Then only the body going to be, the system going to be equilibrium condition, right? Now, I mean this is a P3 double frame, the secondary shearing force. This is a P3 P1 primary P1 secondary shearing force on the bolt 1, on the bolt 1. Now we have found it, shearing force at bolt 1, shearing force at bolt 2, we already know that. I mean here this is a magnitude, I mean here in this case a positive magnitude in the 3 P3 double dash is a positive and the upward direction, P1 double dash negative direction because downward force. But anyway, now we are considering P3 the maximum force. What I told you earlier, we have to take maximum force only. Then I'm considering 10,166 positive force I'm considering. Similarly, I'm considering this shearing force, primary shearing force, directly add together. That will be our resultant shearing force. Once you know this resultant shearing force, go for the your bolt diameter, nominal diameter, bolt core diameter or minor diameter finding. Now see here, this is, I mean P3 by A. P3 by A here, I mean we know the load, P3 we know, and tau we know, tau is already given. Then you can find out this is our DC. This is the core diameter or minor diameter. Then from this we can find out our nominal diameter is nothing but DC by 0.8 standard relation. Then we came to know that, I mean diameter, nominal diameter is 20 mm. Then you go to the table, this is corresponding to M20. Okay, I go to the table and show you first. Yeah. Oh, in this table also not shown. Okay, sorry. Anyway, see here. I mean, don't worry, because whenever fine series, this term will come. The pitch is directly given in the designation. Whenever core series will come, only the pitch, the pitch may not give, the pitch will not be given in the ideal designation. Now M20, M20 here. What is the dimension? Yeah, here. See here. Okay, this is our nominal diameter, this is our pitch diameter. Now you can take it from here, only you are finding nominal diameter and you are taking, I mean our value is nominal diameter is 18 to 9, 18 or 19 mm, but if you want to go for design the component, you can choose this 20, we can't choose 16, we can't choose this 20, only have to choose. But actually I have to show exactly that table. You can go through your book, you can get it, the table also. Okay, okay, I will show you the end of the class, that table also. I have to take from my book only. Okay, now I come to this next. Do you have any doubt, please? If you have any doubt, please go ahead. We are going to discuss the next different type of bolt and joint, how using for perpendicular load. Now this is, now the channel going to be perpendicular to my board. For example, this is a frame, the frame. In this frame, now the frame. Now the next case, the channel is going to be perpendicular to my frame. This is frame. Okay, it looks like the channel is connected in the side, but here next case the channel is going to be perpendicular to the frame. So do you have any doubt in this? I mean, problems, we couple of problems we discussed, and the concept also we discussed. Any doubt, please? Okay, shall we go to next? Hello? Yeah, boss, someone reflect, boss. Hello?
Yes, sir, you can.
Okay, boss. Now, the eccentric load perpendicular to the axis of the bolt. Now, see here, see this figure, yeah. See, earlier case it was in the side. Now this is the channel connected perpendicular to the axis of the bolt. This is the axis of the bolt here. This is the axis of the bolt here. Now the channel is connected perpendicular to the axis of the bolt. Okay. The load is, I mean, sorry, the eccentric load perpendicular to the axis of the bolt. Eccentric load, no, sorry. Okay. Now just keep in mind this, the load is acting here. Earlier case it was like that. In the side it was connected. In the side it was connected like that. Okay. Now in this case the channel or bracket is connected in the perpendicular to the your frame. Perpendicular to the frame, the load is going to be acting perpendicular to the bolt axis. Okay. Now see here, now I mean this is a front view. Here also, I mean the force P is a result in the direct shear. I mean whatever we discussed similar way, here also the direct shear we can easily calculate which method we used earlier, P by number of bolts. That's all. Okay. Now see, this is the load is perpendicular to the axis of the bolt. The load is perpendicular to the axis of the bolt. Now I do one thing. Yeah, this here. Now, see, first we see the theory, then then we go for the explanation. See, some students may not understand. See, the bracket, a bracket fixed to the steel structure or steel frame by means of 4 bolt or 6 bolts. Use 4 bolt or 6 bolt, whatever, maybe based on our applications, based on our load conditions. Okay, it is subjected to eccentric force P at a distance E from the E here, from here to there, the distance E here. This is the distance E distance. E distance. Okay, and that's what we are referring here. Now the force P is perpendicular to the axis of the each bolt. The lower 2 bolts are denoted by 2. I mean the upper bolt 2 bolt denoted by 1. Upper bolt denoted by 1. We'll see that. Now, now this is the lower bolt. This is the upper bolt denoted by 1. The lower 2 bolt we are denoted by 2. Denoted by 2 number, because for our calculation, for our design analysis. Okay, I mean what are the assumptions we are considering here? I mean the bracket steel structure is rigid, the bolts are fitted and reamed and ground holes. Okay, and the stress concentration of the thread is neglected, because stress concentration of thread is neglected while passing through the holes of the frame as well as our bracket. Okay, all the bolts are identical, all bolts are in same dimensions and identical, and materials are also identical. Now come to the shearing force, primary shearing force. I mean here only one shearing force only, because see here the first one is P1 dash, P2 dash is going to be our shearing force, direct shear. This is a direct shear force at the bolt. Now, I mean the bending moment P into E. This is a P into E tends to tilt the bracket. When the bending moment acting, obviously when the bending moment is acting here, what will happen? It is a try to tilt the frame which one is sitting here. This is a try to come out from the frame. I mean, the bracket end where the bolt is connected, when the load applied at this end, what will happen? The bracket try to come out. Try to come out. That diagram only here we are putting here. When the load is acting. Now, when the load is acting. Now, this is C here. I mean, this is, I mean, for our understanding, this is shown here like this. Okay. Now, the bracket is connected here. The load is acting at E, I mean, distance from the rigid structure. I mean, rigid structure. Okay. Then load is acting here. Due to bending moment, here also going to be bending moment. Now, P into E. Then, first we have calculated directs here. Now, what will happen? If the bolt, if the frame, if the bracket is tried to move like this, what will happen? See, if the bracket is tried to move like this, what will happen in the bolt? What type of force will be developed? What type of stress is going to be developed? The bracket is tried to move like this. The bolt is here now. For example, the bolt is connected here. Okay. Then what type of stress will be developed? Anyone please tell that? What type of stress going to be created in the bolt? Tell me, but tell me. Yeah. Now the bolt is like this. While the bracket is bracket or channel is moving towards this direction, what type of stress will be developed in the bolt? Yeah, please tell.
Tensor.
Yeah, tensile. Because I mean, earlier case, you may expect this kind of questions even competitive exam. In eccentric load, perpendicular to the load, perpendicular to the axis of the bolt, what are the stress components? One is primary, one is shear stress, one is shear, another one is tensile. But earlier case, both are shear. Both are shear. Now, sorry. Now in this case, that's what. See here. Now, when we are trying to pull this, I mean, when you are trying to apply the load, that the bracket, it will come out. Then during that time, these bolts are going to have a tensile. I mean, this bolt. I mean, which bolt having more tensile? Which bolt having more tensile? I mean, this top bolt going to have more tensile as compared to bottom bolt. As compared to bottom bolt when the load acting here in this direction. Suppose load acting upward direction, what will happen? When the load is acting upward direction, this bottom bolt, this top bolt going to have this condition. Top bolt is not affected. The bottom bolt going to have more tensile load, tensile stress. When the load is acting upward direction on the channel or bracket. Okay. Now, when the load is acting downward direction, these bolts are going to have more tensile as compared to this bolt. Okay. Now, come to the discussion. Now, I mean,
Hello, sir.
yeah.
Sir, why it is like this?
I see here. When the load is acting, the support. See, 1 minute. Yeah, good question. I come to
Like if I ask you, like, prove it theoretically, like, how can you prove?
what?
Like if I ask you, like if someone will ask us, like, prove it theoretically, like how will we prove that the upper bolts will subject it to more tensile forces than lower bolts?
Yes. Now, see here. Yeah, I come to this 3D diagram. We can easily understand. It is very simple, no? I don't know what is your difficulties. Okay, I explain you that, no problem. Now, apply the load. Now, apply the load, tensile load at the center of the frame, center of the bracket. What will happen? Each bolt, all the bolt going to have the same tensile stress or different tensile stress? Tell me. A good question. Yeah, others also can understand. Now, in this case, the uniform force is acting in the center of the bracket. Now, there are 8 bolts are there. 1, 2, 3, 4. The another side 4. Now, the bolt are going to have the stress is uniformly distributed or different. Yeah, please tell me. You can understand now. I'm explaining
Uniform, sir.
uniform in this case. Now suppose now bolt is now when you apply the load here, what will happen? In practically what will happen, this bolt, this bracket end going to be supported by the frame, then this bracket end going to be supported frame, then here it will be this, I mean upper portion of the bracket going to be come out from the frame, come out from the frame, then it will be a more deflection, here it will be a more deflection, right?
But sir, according to theory, like it is same, na? Like,
Hmm?
like if like if we see it practically, like it is correct what you are saying. But when we see it theoretically, like it is same, right? The
No,
upper one and
no, I have to explain. Yeah, your good question. Now go back. Uh, go back your beam, cantilever beam. When you apply the load, how can you draw this? See here. I mean, I would like to do here tensile. Here going to be compressive, right? Now what will happen when you apply the load? What will happen? Then the top side going to be a tensile, bottom side going to be compressive. Are you understanding now?
yes, sir, due to bending, you are saying.
Yeah, yeah. Now the top bolts going to be subjected to more tensile. The bottom bolt going to be subjected to. I mean, here this bolt is not affected here compressive stress because this is not welded. It's just like bolted. Okay, are you clear now?
Yes, sir.
Okay, a very good question. Very nice. Okay. Now I come to this. Now, I mean, practically we have understood that in the top bolt going to be higher stress, higher load, right? Hence, the delta is, now see, now when you apply the load in the eccentric load, the bending moment will be calculated with respect to point C here. This is a point C here. The bending moment will be calculated with respect to point C. Then distance from this bolt, distance from the point C to this bolt going to be L2. I'm assuming this is a 2 already I indicated. Then the top bolt is the position 1. There's a distance from the distance from the point C, not center, sorry. Where the bracket is ended, when you apply the load, the bracket end is going to be securely supported by the frame. Then this point, it won't be any deflection. At this point, no deflection. Hence, I am assuming the moment with respect to point C. Hence, here, point C, the distance from the point C to L delta 2, C to bolt axis, L2 distance, and then the distance from the point C to our bolt 1 axis L1. Now, obviously the delta 1 proportional to L1, delta 2 proportional to L2. L2. See here, furthermore explanations, see given the basics here. Basic here, stress is proportional to strain, right? Stress, force is here. If you put force is proportional to stress, force is proportional to stress, remove the proportion, put the area constant, okay? And the stress is proportional strain, then remove the proportion, you are putting Young's modulus, material constant, right? That the last one, strain proportional to stretch. What is this? L proportional to delta. L proportional to delta, right? Right. When you put equal to, then the L is equal to what? Epsilon into, sorry, delta is equal to epsilon into L. So that's the same concept we applied here. Same concept we applied here. Delta 1 proportional to L1, delta 2 proportional to L2. L2. Now come to here. Now I would like to, now P1 is proportional. The whatever the condition we applied, considered earlier, the same concept we are applying here. See, therefore, conclude the resisting force included included in any bolt due to the tendency of the bracket tilt. When the bracket is tilting, the resistance force going to be created in the bolt. Resistance force. I mean, that resistance force is nothing but our tensile force. Tensile force. Okay. I mean, that only our intention is we are going to find out that one. Okay. That is, I mean, due to the moment bending, due to the moment P into E. That is proportional to the distance from the from the tilting edge. This is a tilting edge. Tilting edge. I mean, when this increases the length, the delta is going to be increased. Clearly, you can see the practical condition. Also, just imagine it. You can understand. Suppose the bolt is sitting here. Obviously, the delta is going to be delta 3. For example, I'm saying this is delta 3. During that time, the deflection is more, right? That's all. Then similarly, whatever we used earlier, the same case we are using here. P1 double prime, P2 double prime is the resisting force, not shearing force. Please understand, resisting force of the bolt. Then P1 double prime proportional to L1, P2 double prime proportional to L2. So what we considered earlier case, the same case we are going to consider here. Okay. Now go back apply this. Bending moment. Take bending moment with respect to point C. Okay. Now here this force is acting at E distance E, opposite distance E, P into E, P into E. Now what is this? This is a force. This is a moment. Then PE is equal to P1 double prime into L1. L1 here P1. This is a P1 prime resisting force acting in this bolt 1. P1 double prime. Here I multiplied by 2 because there are 2 bolts are there. Then I multiplied by 2. Multiplied by 2. Okay. Plus 2P2 double prime. Here, this is a 2 double 2 prime. P2 double prime into 2 into L2. Two bolts are there. I multiplied by 2. 2 P2 double prime into L2. The distance is L2 distance. And from the distance from the C, L2 distance. Now, from this relation, you substitute your, P1 value. P1 value, you already declared that P1 double prime is equal to CL1. P2 double prime is equal to CL2. Just substitute this equation. Finally, you are going to get a C value here. Once you obtain the C value, then later substitute the same equation for finding your P1 double prime value, P2 double prime value, that will give you a tensile load value. Okay, resisting force value of the bolt 1 and bolt 2. Here playing, two things are playing. One is a tensile, one is a shear, another one is tensile, right? The shear is direct load, due to direct load acting in the bolt. But the tensile is when the bracket applied load, when the bracket tried to long weight, then during that time, this is a tensile stress. Then we are considering these two stress components for defining or designing our bolt size. Okay. Now come to here. What is the shearing stress here? We already know this is a P1 dash, P2 dash. That is a primary shear. Then this is a P1 dash divided by A is our shearing stress. Now, in this case, which one is more stress, more tensile stress going to be? Here we already discussed, no? When the L2 increases, that place going to be a more resisting force. To be required more resisting force, then we are considering that P1 double prime is more resisting force we are considering for finding the tensile stress. That's what here I am considering P1 double prime, because that is far away from the C, this position. Hence I am considering P1 is a more resisting force. Now this is sigma we know, this is a tau we know, this is sigma we know, sigma tensile we know. Now we can go for the principal stress concept, finding the maximum principal stress. Sigma 1 is equal to sigma t by 2 square root of sigma t by 2 whole square plus tau square. Okay, come to the maximum principal shear stress. Tau max is equal to sigma t by 2 whole square plus tau square whole square root. Okay, this is our tau max. Now, based on this component, we are going to find, using this concept, we are going to find out our bolt dimension now. Okay. The cross-section area of the bolts and their size can be determined. The bolt material is usually ductile. Okay, these are the general explanations. This is our standard calculation, standard method. Sigma t is a permissible limit is equal to ultimate strength divided by factor of safety. This is our standard permissible shear stress is equal to, 0.5 times of yield strength divided by FYS. Now I come to this problem.
Sir,
Yes,
excuse me.
tell me, Ba.
Sir, we have Axis Bank OT, sir, now. Can we stop here?
We take up to 4:30, but at least we complete the problem because we don't have enough time to complete the syllabus because vacation, Dasra vacation, right? Now, at least please, I try to complete these problems. Okay, then next one more case is there. I can explain the concept. The problem we will discuss in the next class. Okay, how many problems are there? 1 minute. One, two, these two problems. Okay, very simple. Concept, please cooperate. Okay, because we missed out 2 to 3 classes also. So even though I didn't take any extra class, please cooperate. Okay, now the following data is given for the bracket, listed in the figure. This is a bracket figure given. The load is 25 Newton is acting here, 25 kilonewton is acting here in this bracket here, 25 kilonewton is acting. Is eccentric distance is 100 mm, 100 mm. Okay, 100 mm, and L1 is L1 is given. L1 is given. This is L1 is nothing but the vertical distance from the C, from C to, bolt 1 and 1 bolt 1, under 150 mm. Okay, L2 is distance is 25 mm. L2 is 25 mm. Direct substitution, not a difficult problem. See, this is the standard. They have given material for 45 C8. Then see, ultimate strength is 380 Newton per mm squared. This is a factor of safety 2.5. Now, these are the standard method to finding the permissible shear stress. This is permissible tensile stress. This is a standard method. Okay, sorry. This is not a permissible shear tensile stress. Permissible tensile strength will come later. Okay, this is our direct shear in the bolt, direct shear load, direct shear in the bolt. This one. Okay, this is a P by number of bolts. Here 4 bolts we are using 6,250 Newton direct shear load. Okay, now that is, once we know the direct shear load, find out the tau is equal to 6,250 divided by A. This is the area of the cross section. We able to find out. Okay, first we'll see this step 3 one by one. We'll see the last we are going to find out the based on principal CSS. We are going to find out the bolt size, but we are defining our sigma, our tau. Our tau is in terms of A, bolt area, A, cross section area. Now come to the second thing. This is the second thing. The tensile stress on the bolt. Tensile stress on the bolt is nothing but now. Based on the bending moment calculations, we know already. PE into L1 divided by 2L1 L2 squared. This earlier discussed formula here. This one. From that relation, we able to find out P1 double prime. Only we can go for only P1 double prime because L1 is more length. But L, if we find it out L2, it will be a less load, less only. Hence, I'm going for P1 dash. We no need to go for P2 dash, P2 double prime, because the length is small, is positioned at less length. Corresponding L2, L1 is greater than L2. Hence, this is our direct, I mean, this is our tensile load acting the bolt. I mean, resisting load. Resisting load is a tensile behavior. Okay. Now take this is sigma T P1 double prime divided by A. This also in terms of area. In terms of area. Now go for the tau max. Find the tau max. Principal shear stress. And here in the problem they are clearly given using the maximum shear stress theory. Using the maximum shear stress theory. Hence, we are calculating maximum shear stress theory. Now, this is once you substitute our sigma t and the tau value in terms of A, finally we are going to get this is the maximum shear stress. I mean, maximum shear stress, but even though we have permissible shear stress 76 Newton per mm square, the left hand side is 76 Newton per mm square. Then substitute here you are going to get area. I mean, sorry. Okay. Now in the right hand side in terms of A, we are going to get A. I mean, finally we are going to get A is equal to 98 Newton, 98.02 mm square. Now come to this chart 98. Where is there 98 0.2 mm square? This is nothing but stress area. I think stress area. Yes, tensile stress area. Tensile stress area. Where it is 98. You see the right hand side. This is the possible. We can't choose. Once we have found this, now this is the my bolt destination is M16 into 1.5. In this case only I able to get 98. This is because my dimension is the area of cross section. Mean tensile stress area is 98 mm square, but 98 mm square is not available, but 92 is available. I can't go for that. I can't go for that. I can't go for this also. Then I can prefer this 167. 167 corresponding minor diameter, corresponding internal diameter, internal minor diameter, corresponding internal thread diameter DC, corresponding external diameter DC, pitch diameter. These are the things you can take from the table for your design of bolt and nut. Okay, this is a pitch given. This is our nominal diameter or major diameter. You can take it. I mean, what we are doing here, any one value you are finding. For example, here we have found that tensile stress area. Based on tensile stress area, we are tracking other values of the bolt, and the internal and external bolt dimensions. Okay, that's all. Now come to this is one of the interesting problem. Now see here, I mean this is eccentric load parallel to the axis of the bolt. Eccentric load, I mean see here, this is a connector like this. I don't know in 3-dimensional view. I didn't get the 3-dimensional view diagram. Also, I searched, but I tried to teach you in way of your understanding. Now this is acting like that. Yeah, now in this way, now the bolt is sitting here. Okay, I hope that you have understood. The bolts are sitting here. Okay, are you clear now? Have you understood this? Are you clear? Now, the force, the eccentric load is a parallel to the axis of the bolt. Earlier case, perpendicular. Now, in this case, parallel to the axis of the bolt. Are you clear now? Have you understood this? Yeah, please someone reflect. Otherwise, I can explain another way. Are you clear? Hello.
Yes, sir.
Okay, now come to the problem. A cast iron bracket fixed in the steel structure. You see the figures. This is a figure. Okay. I mean the supports loaded. It supports a load P is a 25 kilonewton here acting 25 kilonewton. There are two nuts, two bolts at A and B. This is A and B. Two bolts and nuts are used to hold this bracket. Hold this bracket. Okay, A and B. The distance are given here. See here. I remove this now. You might have been understood. Now distance is given here L1. I mean when the load is acting because this is the, I mean now in this region here, now this region going to be more stress, here. Now this is L1 distance from this point C2, this bolt pitch diameter bolt center is L2. This is L1 from bolt A to C. A to C is L1. Okay. I mean, you may ask, sir, how it will be? This is going to be coming out as compared to bolt A, because if you take this design of the bracket, obviously this is going to be this side only more effect, more tensile effect. Suppose if you make it reverse, this in this case this bolt, these are the things you have to understand your own way. Okay, now in this case which bolt going to have more tensile, this in this case. So in this case suppose the bracket is like that. Now in this case, I mean here only more this is here, it's going to be more here, more deflection. Okay, now in practical way you have to imagine and understand, imagine it, I can understand. Okay, now in this case, so anyway we go for the problem. Very simple problem, it's not a difficult one. Okay, now see here the distance given. Determine the size of the bolt. If the maximum permissible tensile stress they have given 50 Newton per mm square. Now see here, this is okay, these are the theory. Now come to the direct tensile force. Step 1, tensile force. Direct tensile force. What is the direct tensile force? Here, is there any shearing force in this design? For example, in the side view, yeah, very good question. This is very good question. Is there any tensile or shear? See the side view. The bolt going to have a tensile or shear or only, which case now? In this case, bolt subjected to tensile or shear? Both bolt.
Both, sir.
Both are tensile only, pa. Both the case only tensile. How it will become a shear? Because the bracket is hanging. It's not vertical. The bracket is hanging. See here, this is support. This is the support. In the support, sorry. See the side view. The side view, see here. I mean the side view, see, this is a frame. This is the frame. In the frame, the bracket is connected. It's now hang in the bracket, in the frame, the bracket is hanging. Then now you can't say shear. Are you understanding now? Hello?
Yes, sir.
It won't be a shear.
Yes,
It
sir.
is. This is only tensile. So now earlier, that's what, based on design we have to identify with respect to our basic knowledge. We have to identify. I mean earlier figure is different. See here this is going to be shear. Here it was shear as well as in this case shear as well as tensile like that. At the earlier case both are shear, earlier concept. Now in this concept the bracket is hanging. only tensile. Then find out this tensile, find out the direct tensile load, find out the direct tensile force. I mean, now 25 newton, 25 kilonewton by number of bolts 4. Then this is our direct tensile load. Okay. Now tensile force due to tendency of tilting. When tilting, then when the bracket going to be tilting, then that time what is the tensile load acting? Where the more tensile load? In this case also, this is delta 2. This is the deflection delta 2 at a distance of L2. Okay. Now we know, right, already where the distance is more from the our point of point C, then this is more load. Then here also the tensile force happens. I mean, tensile force, why it's happening? When the bracket tilting, the bolt is try to resist. Try to resist. That resistive force only we are going to calculate now. Okay. Now see here, the same concept, delta 1 is proportional to L1, delta 2 is proportional to L2. This is as we discussed earlier. Now come to direct calculation. Now P1 is P1 double frame going to be C1 L1, P2 double frame going to be C2 L2. But in this case, both P1 frame, P1 double frame, P2 double frame, P2 single frame, all are tensile, but P1 frame, P1, P2 frame are direct tensile. But when the bracket try to tilt, during that time, that resistive force going to be created in the bolt, that is also in tensile. That only we are going to find out here now. Now, this case, I mean, apply the same case. I mean, bending moment. This is the distance P into E. P into E is nothing but P into L. P into L they given. L is given. How much they given? L is now given in the problem. 400 mm. P into 400 mm. Then P equal. Then this is nothing but there are 2 bolts. 4 bolts they have given, right? Yeah, 4 bolts. A and B. But in front view we able to see only 2 bolts. But in behind, in 3-dimensional view, we can see 4 bolts. Then 2 bolts in this region. See here, this another bolt is sitting here, another bolt is sitting here. In 3-dimensional view, you can see that. Okay. Now 4 bolts are there. Now, hence, based on that, I can apply this concept, whatever we discussed earlier, similar concept, 2P double frame L1 plus P2 double frame L2, because 2 bolt here, this is 2 bolt here, this is 1 bolt, this is another bolt. Okay. Sorry, I want to explain clearly here. One bolt is sitting here, another bolt is sitting here. The frame is like that connected. Okay. Now apply. Now apply the similar concept early to find out C value. I mean, substitute this P1 double P1 double frame P2 double frame value, substitute in this equation. Finally, we are going to get our C value. similar concept only. Earlier concept, but the load is both are different. I mean, both case. I mean, P frame case also tensile and P double frame case also tensile only. That's all. Now P2 double frame. Now which one is the more load? More load is in this case. This is away from the C point, away from the tilting edge. This only away from the tilting edge. Then this P2 double frame is going to have a more load. Hence, I'm only considering that. That's all. Then this is the P double frame, P2 double frame load, tensile load. Then what is the total tensile load? Here, both are tensile. We can sum it. That's all. Then, I mean, this is a direct. I mean, in this P2 frame, this is a direct tensile. This is due to tilting. The P2 double prime is due to tilting. P2 prime is direct tensile. Then sum it. That is our total tensile load acting in the bolt. Now, finally, I mean, we know the bolt, we know the, load, tensile load, total and tensile load. Now, I mean, simple calculation. Now, what is the sigma T? Sigma T is equal to P2 divided by A. I mean, A is sigma is given already. This is 50 Newton per mm squared. This we have found it. Now, find it this one. A is, what is A? Once you find out this A, this is a tensile stress area, then go to the table, you can find it out. 595 Newton per mm squared. Then in the tensile table, where it is 595 Newton per mm squared, this one. Then corresponding, sorry. This is the tensile stress area. I know the tensile stress area 595, but this is less than 595. Now I can choose the higher value. Higher value is always safe for our design. Now I only go for this concept, then later we discuss the problem later. Okay, please cooperate.
Sir,
Yeah.
sir, please, sir. It's already 4:40, sir.
Okay, pa. Okay. So next week, can we go for extra classes?
Yes, sir. We will arrange.
It was
Okay,
already.
but give me pa some extra class. Kalyan.
Yes, sir. Yes, sir.
So anyway, I mean, I'm going for I'm not missing any concept in our discussion. That's what taking some time, but even this is the first time for me, so you have to understand that also. Okay, but if you have any doubt, please ask me. First time, second time doesn't matter. I can do better also based on your doubt only. So, I mean, one guy asked a very good question, very good doubt. I mean, I don't know his name. This once we are discussed here, he asked a very good doubt how the tensile stress is more. I mean, based on I mean, I know the basics, but I thought the students may knows that. Okay, anyway, so very good question. So similarly, if you ask the questions only, I able to get back new information. Okay,
Sir, tomorrow 8 to 9 we have free slot, sir. Is it
tomorrow,
okay? Yes.
tomorrow, 8 to 9, huh?
Yes.
Yeah, tomorrow I try, pa. Tomorrow 8 to 9. Any other time?
3 to 4 also we have free slots.
Okay. Before 2 hours, I inform you, Kalyan.
Okay.
Sure. If I'm going to take 8 to 9 class, sure, I inform you at least 6 o'clock. If I'm going to take 3, because I don't know, tomorrow I'm going to some other meeting. So that's what I'm saying. Otherwise, I can assure you now itself. Okay.
Okay.
Morning I'm going to have a meeting with my research scholar. Evening I'm going to have a meeting with some faculty. That's what.
Okay. Okay.
That's I already scheduled, but the time not at is decided. But morning schedule is defined 8 o'clock. Okay. There are few things we improve or we increase our speed in the later upcoming classes. Okay, please, any doubt, please go ahead. I come to chat box. Greater than 430. What is this, Swayap? Are you there?
Yes, sir. It was like by mistake. It was written.
Oh, fourth. Okay. It looks like I couldn't observe that point because my laptop is very small. Then I thought you might have been mentioned any stress value like that. Okay.
Yes, sir. I think it was something like that.
Yes, thank you.